In chapter 2.6, we're dealing with the center of mass. Actually, this formula shouldn't be unfamiliar to many of you, but I guess it could be. This is a similar formula used in statistics. Actually, this is a way that your grades are calculated. So what's involved here? Well, let's take a finite number of points. This finite number of points are labeled x1 through xn. And then you have the masses at each of those points, illustrated by a corresponding m for mass. So if you have n data points and x points, you have to have n mass points along with them. All right, so we've got some summation notation down here. And so it's got this m equals the sum of all of the m's. And we'll use that as well. But basically, what we're doing is we're weighting each of the individual values. So here, our center of mass m equals the sum of the products of all of these. So you take the mass at each value and you add them all up. And that is what your mass is going to be. And the center of that mass is the overall average of them. So if you have 10 of them, you divide by 10. So again, this m is the number of them, you divide. So again, this is similar to how grades are calculated and some of the probabilities for expected values are done. There's a little bit different, but this original process here is going to be the same. So typically in those other things, you assign the mass as a probability or as a proportion, and you're just done and you're finding the m. Here we find the center of mass where we have to divide by the number as well. Okay, the lower theorem is the same thing, only using instead of just on a line. So this top one is on a line. We're going to be in a plane, which means we need an x and a y coordinate, which means we simply need the x bar and the y bar. The x bar is done the exact same way, using only the components for x with those m's, and the y bar is wherever the y value happens to be for that corresponding x. And it's done, the process is the same, only you attach the y's to it. So if you can see here, you've got a capital M with a subscript x. That's going to correlate to your y's because you're multiplying by the y's, and that directly links you to this one, where we have the x, the m subscript x there, and the x bar you deal with the m subscript y. So it's a little counterintuitive. Why not just keep all of the x's with the x's? But this is the notation that they're using, so we're going to use it. So eventually we're going to get a center of mass as an ordinal point. All right, so let's try a couple problems here. Excuse me. So the first problem, number 254, is just going to be a center of mass based upon just 2. So n in this case equals 2. So if we recall our formula up here, we're just using m. So m, capital M, is the sum of I equals 1 to just 2, because n is 2, of the mi times xi. So this equals the first m is 2, and the first x is 1. And we add that to the second m, which is 4, multiplied by the second x, which is 2. So our m is 10, but again, we have to divide by the number that we have. So x bar is capital M over little m, which is going to be 10 over 2. So x bar is capital M over little m, which is 10 over, we have two individual m's, so therefore we have 5. All right, so number 259, it's a similar procedure, but here we're looking at ordinal points, so we're dealing with a plane. So we will find mx, and that will deal with the y's, that sum I equals 1 to 2 of the mi times yi. And here we have 1 times 0 plus 3 times 2, which is equal to 6. And then we have m sub y, which is the sum of I equals 1 to 2 of the mi's and the xi's. So now we look at the x values, so it's 1 times 1 plus 3 times 2, so this is going to be 7. And so our x bar is going to be my over the little m, which in this case is 7 over 2, and y bar is m sub x over little m, which is 6 over 2, or 3. So our center is going to simply be 7/2 and 3, so this point. So this is the coordinates of center of mass for this one.